Hello and welcome again with another video. Now we are going to see the exact differential equation, and this type of equation is so easy to deal with since we have a exact method, as it is named as an exact differential equation, and we have more than one method how to solve it. We have the method of grouping and the method of another two methods. And for today, we are going to see just one method, just to know how to solve this kind of differential equation. And in the other videos, we are going to see some more methods. So let's get started. A exact differential equation can be written as x y. It can be written as xy, which is as a function with two variables times dx plus n xy, which is another function with two variables x and y, dy is equal to 0. This kind of differential equation is said to be exact if and only if it satisfies the derivative of mxy over this is multiplied by dx. We will get the derivative with respect to y. If it's equal to the derivative of nxy with respect to x, since this is multiplied by dy, if it the same, so we said that this is an exact differential equation. A differential equation, here again, a differential equation is said to be exact if and only if it is satisfied this condition, which is the derivative of mxy with respect to y is equal to the derivative of nxy with respect to x. And we have more than one method, as I said before, to solve this kind of uh, equation. Let's see some examples to see how to solve them. Um, Basically, in differential equation, the methods can be seen in some examples. It's not necessary to do the theory part in this lecture. So the first example said solve the differential equation. Of course, 2x minus y plus 1 times dx plus 2y minus x minus y times dy is equal to 0. Now right here, the first thing that we need to see if it is separable. I guess it's not, because we have here 2x dx, it's clear, and we have y dx and we have x dy. They are not going to be separated whatever you do. So it's not separable, it's not homogeneous because of these constant. If we replace every y and every x by tx and ty, we will still have here 1 we cannot return into the first equation. So let's try to see if it's an exact. We said we have this condition. We have the derivative of 2x minus y plus 1, which is multiplied by dx with the respect to y. It's going to be, every non-y is going to be 0, so the derivative of 2x is going to be 0, the derivative of 1 is going to be 0, the derivative of minus y is going to be minus 1. We are going to see if it's equal to the derivative of 2y minus x minus 1 with respect to x. Actually, with respect to x, so this is going to be 0 and this is going to be 0, and minus x with respect to x is going to be minus 1, so it is equal. So right here we can say this is an exact differential equation, and we are going to see the method of grouping. I told you that the equation needs to be in this form. It needs to be in this form. Why? Because we need to see dy and dx, okay? If it's written as y prime or the first derivative by itself or multiplied by something, we need to get it in this form first. Then we will see if it satisfies this condition. After all that, we need to solve it. So let's return to our equation. What we have 2x minus y plus 1 dx plus 2y minus x minus y dy is equal to 0. The first thing that we need to do is to group everything. Like we have x with dx and y's with dy's. And everything is mixed in the other side. So like x dy or something a function of x times dy or something a function of y times dx or the opposite. So what we have 2x dx minus y dx plus dx plus 2y dy minus x dy minus dy is equal to 0. So right here, this is a function of x times dx. This is a mixed. So in the other side, this is dx is going to be this side, and this is y dy and x dy. So it's going to be in the other side. So we will end up with 2x dx. Yes, 2x dx plus dx plus 2y dy minus dy, and this 2 is going to be in the other side. It's going to be x dy plus y dx. Yes, as you can see here, we can integrate the both sides directly, or we can just see what is the primitive of each of the following. And here, as you can see, we have 2x. What is the primitive of 2x? Is going to be x squared. So this is the derivative of x squared plus. And as you can see here, it's dx. What is the primitive of 1? Which is x. So it's going to be the dx, d of x. And what is the primitive of 2y? It's going to be y squared. So it's going to be the derivative of y squared minus the derivative of y. Yes, is going to be equal. As you can see here, it looks like that x dy plus y dx, it's the same as the product of two functions. So let's try to figure out which function it is. It is simply, as you can see here, x and here is y, so it's the product of x of y, x and y, which is the d of xy. So when we get the derivative of x times y, it's going to be x dy plus y dx, and this is all what you need to know. We are not gonna get we are not gonna get some complicated function from this side. It's gonna be clear, I think. You're gonna see it. And in this step, we need just to integrate the both sides and to get our equation. By integrating and everything, by integrating, we will get x squared, since the derivative with the integration is cancel out. So it's going to be x squared plus x plus y squared minus y is going to be equal to xy. We don't forget c. So this is our solution for this equation. I think everything is clear. We are going to see some more examples to make things clear. Yes. I'm not going to deal with a second method. I just want you to focus on this method. On this method, since it is easy and Simple. Let's see another example. It said like y over x dx plus y squared plus ln x, it's not the absolute value, dy is equal to 0. The first step that you need to see if it is separable, it's not, because we have dy times something multiplied by x, and we have x times something multiplied by y, so it's not separable. We need to see if it's a homogeneous, so we need to replace t by t, and here is going to be cancelled, and here is not. We will have t squared right here and ln t right here, so it's not homogeneous. So now we need to see if it's an exact differential equation. Let's see the derivative of the thing that multiplied by dx, which is y over x, this is y, and with respect to y, since it is multiplied by dx, so we need to see it with respect to y. And we will consider 1 over x as a constant, so 1 over x times y, which is 1 over x. We are going to see it if it's equal to if it's equal to the derivative of y squared plus ln x with respect to x. With respect to x, so y squared is going to be 0. The derivative ln x is going to be 1 over x. So it is equal. Actually, it's equal. So we are in the case of exact differential equation. And now we are going to solve it. As I told you, now we have what we have. We have y over x dx plus y squared dy plus ln x dy is equal to 0. As I told you, before, here we have, I think, is multiplied by x and y. So, and here is only y's, and here x and y. So we need to get it in the other side. What we will get, we will have y squared dy is going to be equal y over x dx minus ln x dy. Right here, what is the primitive of y squared? It is 1 over 3y cubed. Yes, which is the derivative of this. It's going to be the derivative of this quantity is going to be this. And on the other side, as you can see, it is the product of something. Let's say that we don't know. We have minus. First, we are going to get minus of the derivative of something. How we can get it? What is the primitive between something that contain x, which is 1 over x, and ln x? So it is ln x. We need to write the primitive times. As you can see here, we have a y, and here we don't have, so we have 1. We have 1. So what is the primitive between 1 and y? It is actually y. So if we get the derivative of ln x times y, we will end up with this. So it is 1 over x times y, and the derivative of y, which is y times ln x. So by integrating both sides, we will end up with 1 over 3y cubed is equal to minus ln x times y, and we don't forget c. So it's going to be 1 over 3y cubed plus ln xy, this is going to be here, is equal to c. This is the final solution of our example. I think the method is clear. Let's see another example. And The third example said solve the differential equation, of course, of 2x cosine y plus 3x squared y times dx is equal to plus, sorry, y x to the power of 3 minus x squared sine y minus y dy is going to be 0. In this case, what we need to see if it is separable. It's not, because we have something is multiplied by dx and it contains y, so it's not separable. Secondly, we need to see if it's homogeneous. No, it's not, since cosine x and sine x are not linear. Third, now let's see if it's a exact differential equation. We can confirm it is an exact differential equation by getting the derivative of 2x cosine y plus 3x squared y with respect to dy. With respect to dy. So x is going to be a constant. So it's going to be with respect to dy, and the derivative of cosine x with respect to dy, it's going to be 2x, since this is a constant, times the derivative of cosine y is going to be minus sine y plus 3x squared. Now we are going to see if it's equal to the derivative of x cubed minus x squared sine y minus y over dx. So it's going to be 3x squared. The derivative of x cubed is going to be 3x squared. It's the same as this. And minus 2x sine y, and the derivative of minus y is going to be 0 since it's a constant. And this is equal to this, so it is an exact differential equation. To solve that, as we said before, the method of grouping, we will separate we will put, okay, let's start. We have 2x cosinus y in a side, and with this, because as you can see right here, we have x and y and dx, and we have x and y, and here as you can see we have x cubed, and here we have only minus y dy in a side. Okay, it's gonna be 2x cosine y dx plus 3x squared y dx plus x cubed dy minus x squared sine y dy is going to be equal to y dy. What should we do right here? What we have x cubed with its derivative is going to be x squared, so we need to link between these two. Okay, and as you can see right here, we have cosine y and we have sine y, so one of them is the derivative of the other. So sine y, the derivative of sine y is going to be cosine y, or since we have the minus, so cosine is going to be the derivative of sine. But since we have here we have x squared and 2x, so we need to link between these two. So it's going to be the derivative of x squared. Since we have the minus, we need to see if it's a cosine. Yes, it is a cosine. Since this is the derivative, so this is the function. And we will plus, sorry, the derivative of x to the power of 3y is equal to the derivative is going to be 1 over 2y squared. Yes, by integrating both sides, we will end up with our solution, which is cosine y times x squared plus x cubed y is equal to 1 over 2y squared plus c. And this is our solution for this equation. And I hope that you have understand, and this is the end of the video. I hope that you get the idea how to solve this kind of differential equation. See you in the next videos.